Retrobotics.
Welcome back to Retrobotics. In the last episode, we showed that the Major Havoc board set would at least boot to, well, something and play some semblance of the sounds of the game, but the screen was absolutely screwed up, as shown here. Taking a closer look at this, one might recognize a few things. One, there appears to be relatively flat lines on X. Like that is gotta be the scoreboard. That's, 10 rows. That's gotta be the high score table. So whatever is happening here is only affecting the X-axis. The Y-axis is pretty much okay, one would think. So when something like this happens with the axis in particular, we had something like this about 2 weeks ago on our Space Duel, actually. It turned out to be the DAC. So let's take a look at the schematics for Major Havoc. You can see the DAC here, highlighted out in the blue box. This takes input from the rest of the game, PCB and digital, and turns it into an analog signal, which is adapted and sent out. Now, in the X-axis of Major Havoc in particular, this is somewhat interesting. For the conversion boards, Atari actually cut out all of this section over here past the red circle and placed that on the adapter card. I'm not sure why, but you can see that it's jumpered from that spot, pin 7 on the LF201, which is shown in the purple box, all the way to the edge connector. So, when faced with this issue, I pulled a DAC off of our spare Space Duel board and popped it into the PCB to see what would happen. Let's take a look. Okay, I'm plugging in the game board now. Everybody pray with me. Let's see. I hear deflection. I see an image. There it is. Look at that. Oh, I'm so excited to play this. But whoops, what the heck is that? The rest of the vectors look okay, but the ship is off. So what could cause that? Well, in the linear adjustment section of the circuitry, there is the BIP pot, which is over on the right here. And that allows you to basically line up the vectors. BIP stands for bipolar, and it allows you to provide offset current, converting a unipolar DAC to one that provides bipolar output. And I'm quoting the 6100 FAC there. And you can see trying to adjust it from that bit pot did not work so well. Try as I might, the top right part of the crosshatch just would not go to the right side. So you're getting that weird spaceship going on there. So if it's not the pot, let's backtrack a little bit. And there we have the DAC at 11C. It's another IC that I could scavenge off of our Space Duel board. So that's what we did. Pulled one off and put it in, and looks much better, doesn't it? Well, that was all well and good, but what about the sound? Notice this horrible music playing. That's definitely not right. The sound in Major Havoc comes from a chip called the Quad Pokey. Quad Pokey is quite literally 4 pokies. Atari used this on Firefox, Major Havoc, iRobot, and Return of the Jedi. Now, these Quad Pokies, as they were originally one chip, were prone to failure, so Atari released the Quad Pokey Eliminator, which allows you to plug 4 regular pokies into a standard PCB. And a lot of the Major Havoc conversions, they had a Quad Pokey Eliminator. Ours does as well. So, generally with an Atari game, if you've got some sounds working and some sounds not, you pull off a pokey and see if you can swap it around with a known good one until you get good sounds. Unfortunately for us, Swapping out that pokey didn't actually solve anything. In fact, swapping out all 4 pokies resulted in the same bad sounds. So, it's not the pokey, and it's probably not the processor on the gamma side either, which handles audio, because that also handles controls and dip switch settings, which were working. So, something in the middle then. If we take a look at the audio diagram, we see that the quad pokey communicates through the LS245. There. And before we pull off an LS245, the thing to do would be to sound out all the connections between the quad pokey and the LS245. We did this by removing the quad pokey from the board because, well, it's enormous and you can't actually get to the LS245 unless it's off the board. And in doing so, found that there is actually a bad connection. And the connection was between pin 6 of the LS245 and pin 12 of the quad pokey. So, to solve this, we put a jumper in place, as it wasn't possible to resolve this through simply reflowing the solder, and then we put it back in the cabinet and fired it up. Sounds much better, doesn't it? The monitor doesn't look so good, though, blooming in and out like that. That's not a game board problem, though. We were working on the monitor in parallel with the game board on this, and, well, the game board finished first. And just happened to be good enough on the monitor to get some display out. This is probably a high voltage issue, and we'll be discussing that further in our upcoming How to Bring Up a WG6100 Monitor video. Anyway, I hope you've enjoyed this sneak peek at Major Havoc gameplay. I know I did. And we'll see you next time with our monitor repair video.